Lithium ion batteries have become a ubiquitous part of the digital revolution, but not without a serious setback. They keep spontaneously exploding, and consumers are getting sick and tired of it. So, what's the underlying issue, and what the heck is science doing to fix it? Today we're talking batteries, folks, and the future that's being charged up in the labs. Now, before we get into explosions, let's recap how batteries work. Electricity is all about the flow of electrons through a conductive material, and a battery is a way of storing and controlling that flow. These are the four basic parts of a battery. To keep it simple, the electrons flow from the negative anode around to the positively charged cathode. The electrolyte is usually a fluid in between the two. For more on how batteries work, go ahead and click on this thing. Lithium is a current standard for cathodes. It allows for the easy transfer of electrons, and it's lightweight, making for a more portable battery pack. Lithium-ion batteries usually employ lithium cobalt oxide as the cathode, graphite as the anode, and a lithium salt bathed in a mixture of one or more alkyl carbonates as the electrolyte. Even though these materials have helped make portable, relatively efficient batteries, they don't come without setbacks. Let's not forget that lithium is an alkali metal, meaning it's highly reactive. Not to mention, organic electrolytes like dimethyl carbonate are extremely combustible. The lithium and the electrolyte are two pieces of the flaming hot chemical puzzle that's known as thermal runaway. Thermal runaway is what happens when a battery cell spontaneously explodes. There's a few different reasons why this happens: the overcharging of a battery, overheating, physical damage, or faulty manufacturing resulting in electrical short. This is what happened to those blow-up Galaxy 7s. To keep it simple, anything that can lead to a rapid increase in heat can cause you a problem. When multiple chemical reactions cause superheating, the lithium cobalt oxide begins to release oxygen, which can react with alkyl carbonate and even the leftover cobalt oxide. Also, during overcharging, the alkyl carbonate can break down, creating carbon dioxide gas that will expand outward and burst the electrolyte open, exposing its flammable contents. In laboratory studies on thermal runaway, two flammable gases, hydrogen and methane, have also been detected, as well as temperatures as high as 850 degrees Celsius. That's pretty darn hot. And you definitely don't want that kind of heat by your face. In 2013, a teenager received third-degree burns due to the thermal runaway of a smartphone battery. This has become common enough that the FAA has recently banned certain smartphone models from planes. The National Transportation Safety Board has even issued alerts regarding lithium batteries as air cargo based on investigations from a plane crash in 2011. Needless to say, it's not a good sign when a factory that makes these batteries goes up in flames, which is exactly what happened earlier this year. So wait a minute, why hasn't this problem been scienced out of existence yet? Well, wouldn't you know, it looks like the future of lithium-ion batteries might rest in the hands of one of its co-inventors, John Goodenough. He recently led a group of researchers on a quest for a better battery. They came out with one that's non-combustible, lasts longer, and carries 3 times the energy density of current forms of batteries. Goodenough's team believes their newest innovation is safer because the electrolyte is solid glass, which cuts out the flammable alkyl carbonate. It's better at storing energy, would charge and discharge faster, and could be physically shaped into more options. And that's just one of many new battery designs in the works. So things are looking pretty good for lithium-ion batteries. We might be able to look forward to a future where exploding batteries are a blast that stays in the past. If you have any questions about the chemistry of your gadgets, go ahead and post them down in the comments for us, and we'll try to get back to you about them. Don't forget to hit thumbs up and subscribe on the way out, and we'll see you again soon.